Friends, today we are going to discuss a very important topic of vertical farm assembly procedure. Before we going to start assembly of vertical pump, we have to see the pre-assembly inspection. Look at the pre-assembly inspection, like the clean of all components thoroughly, just like shaft, column pipes, impeller, bowls, spider, bushes, etc. for any rust or darts or any damage, etc. And then check for transportation or machining damage if any, and verify dimensions against the approved drawing. The next is we have to check the trueness of the shaft. How to check the trueness of the shaft? Keep the shaft between two V blocks, put the dial gauge on the shaft and measure its deflection. TIR means total indicated readings. It should be less than 0.05 millimeter per meter length and maximum less than 0.1 millimeter. And the surface roughness in the journal portion, particularly the sleeve, where the sleeve has been coated, there its surface roughness should be less than 0.1 micron, and there should not be any score or taper. Then third one is we have to put the bushes and brush for cooling arrangement, bushes and bush for cooling arrangement, that we have to press feed it. You can see in the particular picture that it is made of brass. So this, you see the spiral given from where the water will flow for cooling. Through this hole water will come, and through this spiral it will go outside. So the direction is very important. So group aligned with cooling water flow direction, that should be very important. Then the clearances between bush and the shaft sleeve should be 0.15 to 0.3 millimeter if nothing has been mentioned in the OEM, original equipment manufacturing. If they have not mentioned anything, then we have to maintain a clearance of 0.15 to 0.3 millimeter, depending on the size and material. Then cooling provision, holes should be holes or slots are open condition. External flushing line should be cleared. Cooling water path is continuous, and the rubber should be weighted before the shaft inserting into the insert into the bush. Then spider should be used. Install spider inside the column pipe as per the assembly drawing. Spider location position centrally to support the shaft radially. Spacing between two spiders should be normally, if not mentioned in the OEM, then 1.5 to 3 meter. Check the spider concentricity with the column pipes. It should be concentric, means the center line of the spider and center line of the pipe planes should be same. Then firmly seated, spiders should be firmly seated, properly locked. And whenever it is not mentioned, you can weld it also, and verify the bush inside the spider is not damaged. Then column pipe also, one by one column pipe you have to install. Pipe, then spider, then again pipe, column pipe you have to install. And when you are and tightening the column pipes, bolt diagonally opposite means 0 to 180, 90 to 270, and again check the verticality of the column. You see that the particular drawings that there are two columns are there, and the discharge line is from the side, suction is from the bottom. You see, and therefore you need to give a flushing arrangement from external flushing arrangement to the spider bushing. Here the flushing, here there no flushing is required because pump suction is from the bottom and discharge through the column. So bushes inside the column will be automatically flushed, automatically lubricated through the fluid itself. Then shaft assembly, when the vertical pump are assembled with 2-3 shafts, then shaft sleeve should be threaded. Insert the shaft carefully through the bushes from top, and then clean and oil the coupling threads between the two shafts. You have to couple it, so that with the thread coupling normally we using, so that oil should be used before tightening this coupling threads. Then tightening this shaft coupling to the specified torque. Check out the runout again. Check the runout again between the when you are tightening the sleeve, there may be some runout, but that to be avoided. So you have to check the runout between that from top to bottom, and rotate the shaft by hand and so see whether it is free or not, without, and there should not be any bending. Then impeller and float setting. When you are, then you have to install the impeller. You see, this is the impeller inside the bowls. This is the impeller. This is the strainer. This is the impeller. You see, this is the impeller. So assembly impeller into this shaft inside the bowl assembly. Inside the bowl assembly, tight the impeller log nuts or key as per the design. Then set the impeller float. Typically float should be got how much? Thrust bearing will be there at the top. Here at the top. So 0.2 to 0.5 or OEM, whatever they have mentioned. Then how do you measure the float? Now you have to lift the shaft with dial gauge, dial indicator. Lift shaft upward fully, push it downward, then measure the total distance covered, and that will be your total float. Impeller, adjust the adjust if it is not matching, then you have to add or remove the seams on the impeller, and then top adjusting nut. There is a top adjusting nut is also there. Accordingly, you can change the position of the impeller or shaft. Ensure impeller does not rub with the bowl during rotation. This impeller should not touch the bowls. Here you see you are taking suction from the bottom and passing through this column pipe. These are the shaft. These are the shaft. This is the coupling. This is the coupling. This is the spider sleeve. This is the spider. And this is the bearing position. This is the bearing position. This is the coupling of the motor and coupling of the pump shaft. Now, how will position the impeller? Normally, impeller to be in our thumb rule, impeller to be kept at the middle of the volute. So you have first measure the gap, axial float, and keep the impeller down up to the middle position, then lock nut it and tight the lock nut over the bearing. This is the normal procedure, but you have to do some calculations before calculation, because due to the weight of the impeller, the weight of the shaft, there will be some elongation of the shaft, which we come to know from the Hooke's law, that is sigma is equal to E by epsilon. Sigma is the stress that I know, the F by A, weight divided by A. A is the surface area of the shaft, so you will get the stress value. E is the Young modulus. So if you know this, so you can calculate how much strain is there and how much expansion takes place of the shaft due to the weight. Then if the pump is handling some fluid which is having a temperature, then there will be some expansion. That expansion will be how come to know? L2 minus L1 is equal to L1 alpha T. L1 is the original length, alpha is the thermal coefficient, delta is the temperature difference. So you will come to know how much expansion will take place, how much elongation will take place due to the shell weight. So you have to add the two, and then you have to keep the impeller position above the center line, adding this to value, so that when it will be running, the impeller will come down, and due to thermal expansion, due to strain, and it will be running at the center of the volute. So these are the very important thing you have to keep in mind. Then thrust bearing, in this position you have to keep your thrust bearing to be locked, so that impeller will be slightly above the center line of the volute, so that when it will be running, due to temperature and the expansion, it will come to the center position, and then center position. Then what we will do now? Thrust bearing, check the bearing lubrication. If bearing oil lubrication, you have to put the oil and grease. Then you have to install the motor, and then mount motor and align the motor shaft with the pump shaft. Then do the alignment checking. Angular and parallel alignments, misalignment should be within the limit. That is, value should be parallel should be less than 0.05 millimeter. It should not be more than 0.5 millimeter, and angular should be 0.05 millimeter per 100 millimeter. So this is the angular misalignment is allowed. This is the value. So, and then you first you do the rough alignment with piping, then you do the full alignment with laser or with dial gauge. Then final check, you have to rotate this shaft by hand. See, there is no rubbing, no noise resistance, there is no resistance, no noise. Then shaft trueness, verify you have already you have shaft trueness after full assembly. Proper boost cooling is already, water flow is there, established water flow. Correct spider position is perfectly in the location as per the drawing, and the correct impeller float that I have already explained. Ensure all fasteners are tightened and locked with the lock nut or etc., lock washer and etc., and record assembly measurement in the QC checkbook, so that before running this should be recorded. So ensure, then you have to pre-commissioning, you have to ensure the pump is fully primed, so it is fully of water. Then start boost cooling water before pump start. If external flushing is there, then external flushing pump should be started, so that boost will get lubricated. Then run the pump at no load and take the measurement of vibration, bearing temperature, noise, and then gradually open the valve and take all the reading again and keep on monitoring. This is, I think, I have completed all the slides, and if you have any doubt, you can ask me through my mobile, through my email, and there may be some questions when you are facing the interview board. Ask how to keep this rotor impeller positions, what is the purpose of bushes, etc. These are the types they may ask question to you, and if you go through all these things, then you can reply it properly.